Did you know that it's becoming more common to be born with 6 fingers on each hand? The human body is a perfect machine, designed to adapt and overcome any challenge. From our arms, built to throw objects with precision, to our senses, capable of detecting even the slightest changes in our surroundings, we are the result of millions of years of evolution. Today, we'll look at 15 of the most incredible human adaptations. Let's watch it. It's fascinating. Polydactyly. Something very interesting is happening with our hands. Right now, humans are starting to be born with extra fingers. Yes, you heard that right. This condition, known as polydactyly, means some children are born with 1 or even more fingers than usual. Sometimes these extra fingers aren't particularly functional, so a couple of generations ago, they were surgically removed. But increasingly, these extra fingers are turning out to be fully functional. The craziest part? The gene responsible for polydactyly is dominant, making it easy to pass on to your children, which means the number of people with this condition will likely increase over time. In fact, different regions of the world show various types of polydactyly. In Africa, the condition often results in an extra pinky finger, while in Europe, a second functional thumb is more common. In Asia, extra middle fingers are more frequently seen. Now, since fingers are so important to our species, it's possible that, if a healthy version of the polydactyly gene appears, it could spread throughout human populations over time. So if we give it 3 or 4 generations, it's possible that our descendants might have more fingers. The bajau. One reason humans have spread across the planet is because we are particularly adaptable. Our bodies work efficiently at high altitudes, sea level, in jungles, or deserts. That's why there are human groups in almost every climate and environment. However, there are some human groups that have adapted their bodies specifically to certain habitats, evolving to thrive in environments their culture has chosen. A remarkable example is the Bajau people, also known as the sea nomads, or gypsies of the sea. This ethnic group lives in Southeast Asia, particularly in the waters of the Philippines, Malaysia, and Indonesia. They are primarily a nomadic people, so the concept of belonging to a country doesn't quite apply to them. They belong to the sea, and for centuries, they've survived on small boats and floating platforms, mainly focusing on fishing and underwater harvesting. Living this way means that the Bajau regularly dive to great depths, and since they don't have much diving equipment, this lifestyle has led them to evolve unique adaptations that allow them to dive and stay submerged much longer than the average person. For example, studies have shown that the Bajau have much larger spleens than other populations. This allows them, when they dive, to release extra oxygenated red blood cells into the bloodstream, which helps extend the time they can spend underwater without breathing. But their adaptations don't stop there. Like many marine mammals, such as seals or otters, the Bajau experience a slowdown in their heart rate when they dive. This response, known as diving bradycardia, helps conserve oxygen by slowing the heart rate, prioritizing the supply of oxygen to vital organs, like the brain. Studies also suggest they've developed a higher tolerance for hypoxia, meaning they can function with lower oxygen levels in the blood during prolonged dives. A normal human can hold their breath underwater for a maximum of about 3 minutes, but the Bajau can last almost 13 minutes and dive as deep as 230 feet, 70 meters, without any diving equipment. If we give evolution a couple of million years, the Bajau could evolve into real-life mermaids. Arctic cold adaptations. Similar to the Bajau, other human groups have adapted their bodies to the conditions of their environments. Perhaps one of the most interesting examples is the populations living in Arctic regions. Now, there's not just one Arctic people. There are several Arctic ethnic groups, such as the Inuit in Greenland or the Siberian populations of Russia. Each group is unique, but in all cases, they have evolved 1 or 2 adaptations that allow them to survive the extreme cold near the North Pole. For example, the Inuit of Greenland have a metabolic adaptation that helps them process fat and maintain a thicker layer of body fat than any other human group. This is necessary because culturally and out of dietary need, they regularly eat marine mammal fat, so their bodies have adapted to a fat-rich diet. Likewise, almost all Arctic cultures, but especially those of Siberia, have developed a circulatory system that prevents frostbite from setting in too quickly. allowing them to use their hands and arms even when they're numb from the cold. Pattern recognition. Perhaps the most important human adaptation is our massive brain. After all, we didn't conquer the world because we were the strongest or the fastest. We did it because we were the smartest. So our ultimate adaptation is the brain. But did you know that the human brain has its own set of adaptations? You see, our minds are basically pattern recognition machines. For centuries, staying alive depended on learning to recognize and understand patterns in the natural world, like the changing seasons. If you know that winter comes after fall, and it's a repeating cycle, you can prepare and survive. That's exactly what our ancestors did. That's why our brains are constantly looking for patterns. This is also why things like rhythm are so natural and almost hypnotic for us. Watch this. It only takes a couple of seconds of seeing and hearing the rhythm to understand the pattern behind it. That's because our brain is a fantastic pattern recognition machine. But we're also a highly social species, so recognizing the biological patterns that form a human face is vital. That's why our brains are always looking for faces, even where there aren't any. This is why these cute objects here seem to have happy or sad faces. This effect is called pareidolia. It happens because our minds are so good at spotting the patterns that form a face, we can see them even when they don't exist. And this ability is so advanced that we even assign emotions to these non-existent faces, because we're not just wired to recognize faces, but also to read their emotions. Tell us in the comments, have you ever spotted a face where there shouldn't have been one? Catapult arms. Predators are always born with adaptations to hunt and kill their prey. Claws, teeth, beaks, tentacles, and sometimes electric or venomous organs. Humans aren't an exception. We also have a lethal adaptation. It's just not as obvious as, say, a crocodile's teeth. You see, human arms are incredible when it comes to throwing objects. In fact, we have several specialized structures that help us take an object, be it a stone, a stick, or preferably a spear, and throw it with remarkable speed and force. So much so that even an 8-year-old child, with minimal basic training, can throw objects at speeds that can be lethal to most animals if they hit them in the head or chest. This is thanks to several adaptations unique to humans and that we don't find in other primates. For example, our torsos can rotate independently of our hips, helping us add more force to the projectiles. Our shoulders are modified in such a way that they act as a lever, allowing us to apply even more power to our throws. Finally, our humerus allows us to move our arms further back, storing some elastic energy before launching the projectile. So, beware, food chain. We have catapult arms, and we won't hesitate to use them. Drinking milk. All mammals drink milk, meaning it's part of the package deal. After all, the word mammal comes from the same root as mama, as in mammary glands. So yes, being a mammal means drinking milk. But humans developed a rather unique adaptation when it comes to drinking milk. Our species became the only mammals capable of digesting lactose after adulthood. Well, most humans anyway. You see, all mammals can digest lactose using an enzyme called lactase. However, this enzyme is no longer produced once the animal reaches adulthood, since in most cases, animals don't drink milk once they're weaned. But in certain human populations, this enzyme continues to be produced throughout life, allowing adults to consume dairy products without digestive issues. This adaptation has occurred in several human populations in a convergent manner, usually in response to the domestication of animals that produce milk, such as cows or goats. Genetic studies have shown that lactase persistence originated around 7,000 to 10,000 years ago in Europe, particularly in regions where cows, sheep, and goats were domesticated. This mutation allowed people to continue consuming milk, which was an important source of nutrients, especially during times when other foods were scarce. Similarly, in some populations in Africa and the Near East, lactase persistence evolved independently. In these regions, livestock farming and milk production were also vital for survival. In the Americas, since there were no domesticated animals that produced drinkable milk, populations did not develop this mutation, which is why many Native Americans are lactose intolerant. A similar situation occurred in the Far East, but in their case, the adaptation didn't arise, not because there weren't milk-producing animals, but because culturally, it wasn't done. There were usually more food resources, so people didn't need to rely on milk for survival, and therefore didn't develop the mutation. Hence, lactose intolerance exists. Today, it's a genetic lottery whether you can tolerate lactose, but as genetic engineering advances, it's possible that in the future, you could become lactose tolerant at will with some gene therapy. Blushing. Humans are the only animals that really blush. Blushing is an entirely instinctive and automatic response from the nervous system, so much so that even the best actors in the world who can cry and laugh on command can't trigger this reaction. No one can fake blushing. It's perhaps the most honest reaction our body has. But why exactly do we turn as red as an anime girl? Well, scientists aren't 100% sure, but it's believed to be some kind of automatic social signal related to shame and other social situations. For example, if we do something that is socially frowned upon, we feel embarrassed, and this makes us blush, signaling to our social group that we recognize what we did was wrong. It also plays a role in the whole dating process. After all, you wouldn't blush while being with someone you have no interest in, or would you? Tell us in the comments. What was the time you blushed the most? Sweating. Whew. It's so hot here at the Incredible headquarters. I'm sweating like a pig. Or maybe I shouldn't say that because pigs actually don't sweat at all. In fact, sweating is almost entirely a human adaptation, and no other animal sweats in the same proportion as we do. Yes, it's a bit gross to think about, but sweating is part of the human experience. But why? Well, the thing is, our species evolved in the African savannas, which isn't exactly a cold place. In fact, the tropical plains where we evolved can be brutally hot, which is why humans had to develop thermoregulation systems. Initially, we lost most of the fur on our bodies, but that wasn't enough. Over time, we developed sweat glands all over our bodies, and since our skin was exposed, it offered a perfect surface for sweat to evaporate. The way evaporation works, it cools the body by reducing the temperature. As a result, humans are one of the only mammals almost completely invulnerable to overheating, which means we can chase prey for miles before needing to rest. Our body cools itself automatically, and the advantage of sweating is that it spreads the cooling effect all over the body, rather than being limited to specific areas like the mouth or paws, as with dogs and cats, who have to pant to reduce their temperature. Of course, this adaptation means humans dehydrate more quickly, so we have to live near fresh water sources. But hey, pros and cons. And now that deodorants exist, sweating isn't so bad. Domestication. Humans are so incredibly adaptable that even the plants and animals in our environment adapt to us. Or is it the other way around? Did humans domesticate plants and animals, or did plants and animals change us? Well, that's the eternal question about the incredible phenomenon of domestication, which was undoubtedly one of the tools that led us to the modern world. Without domesticated animals and plants, there wouldn't have been human civilizations. You see, domestication is a strange two-step dance between symbiosis and directed evolution. At first, all the creatures we ended up domesticating started their journey as beings that benefited from our presence. Take dogs, for example. At first, they benefited from the leftovers of our hunts, and by cooperating with us, the survival chances of both species improved greatly. The same goes for plants, which benefited when a species scattered their seeds everywhere and had the reasoning and tools to actively bury the seeds, giving them the best chance to grow. So without domesticated plants and animals, our species wouldn't have progressed, and these species, in response, began co-evolving with us. But at some point, we started directing this co-evolution for our benefit. And now, without these species, humanity is in trouble because we no longer have the capacity to be hunter-gatherers. We depend on them as much as they depend on us. It's beautiful when you think about it. Humanity and domesticated species together against the world. Evolution of the Sherpas. And getting back to the theme of human groups that evolved to live in certain environments, let's talk a bit about the incredible adaptations of those who live in the highest mountain range in the world. We're talking about the Sherpas, an ethnic group that inhabits the mountainous regions of Nepal, particularly in the Himalayan area. Known for their amazing ability to live and work at extremely high altitudes, where most people can barely breathe. To achieve this, the The Sherpa ethnicity has evolved special blood that transports oxygen more efficiently without the need for extra red blood cells, which is how most people adapt to high altitudes. Additionally, Sherpas have greater lung capacity, which allows them to breathe the thin air of the mountains and make better use of air that simply has a lower oxygen concentration than at sea level. It's also known that their blood chemistry is very different from others, as they have high levels of nitric oxide, which helps dilate blood vessels and better oxygenate the body. These adaptations are believed to have occurred over a period of about 30,000 years, since the ancestors of the Sherpas and Tibetans began settling in the Himalayan regions. During this time, natural selection favored individuals whose physiological traits allowed them to survive better in an environment with low oxygen levels. Interestingly, these adaptations are unique to the Himalayan people, as other highland peoples, such as the Quechuas and Aymaras of the Andes, have adapted to altitude differently through increased red blood cell production. The human hand. One of the adaptations that helped us dominate the world is the use of our hands, especially our fingers. They are among the most precise appendages in the animal kingdom, to the point that almost no other animal has the same level of control over their appendages as we do with our hands and fingers. This is thanks to millions of years of evolution that gave us some of the smallest and most precise nerve endings, tendons, and muscles in the entire animal kingdom, all right in our hands. As we can see here with these preserved human hands, the inside of the hand is incredibly complex, with ridiculously intricate systems of tendons and muscles that innervate and connect the entire hand. The system that innervates the hand is particularly interesting because it follows models similar to those used by trees to create their branches. It originates from a central nerve, like the trunk, and then branches out to each finger. And if that wasn't enough, the hand is also one of the most joint-rich areas of the body, with 29 joints and 123 ligaments in total. That's so complex that roboticists often avoid copying the human hand perfectly, as we still don't have the technology to replicate what we do with our hands. And all of this because once, an ape started walking on two legs, freeing up its hands. Fermentation. Did you know that one of the things that allowed us to advance as a civilization was the fact that our ancestors used to get drunk on rotten fruit? Yes, it sounds strange, but it's true. And in fact, neither you nor I would be here if it weren't for that. You see, humans evolved from primates, which are mainly frugivores. So, since the dawn of time, our lineage has eaten fruit, and something interesting happens with this food. Sometimes the fruit falls to the ground and ferments naturally, creating alcohol and aromatic compounds. For most herbivores, this could be dangerous to their health. But since our ancestors had to eat fruit, even if it was in moderate decay, our lineage developed a natural resistance to alcohol and other fermentation byproducts to the point where not only can we process alcohol, but we can derive calories from it. This is why you get a belly if you drink too much beer. Of course, today this can be a problem, but for our ancestors it was an incredible advantage because fermentation allowed them to increase the calories they could get from a single harvest. That's why the Egyptians ate mostly beer, just like my uncle. But seriously, the ability to process fermented compounds really changed the course of history, allowing people to store food, not just in the form of wine and beer, but also in cheeses and breads that were a main food source for much of history. And all thanks to our species' ability to withstand fermentation. Well, actually, it's because our primate ancestors were a bunch of drunks. But hey, one thing doesn't change the other. Laughter. Haha, what a way to laugh. But did you know that laughter is one of the most human behaviors there is? Yes, that's right. While some animals, like dogs or cats, may have expressions that resemble a human smile, and some social animals, like chimpanzees and rats, have expressions that seem similar. Our species is the only one in the entire animal kingdom that laughs with big belly laughs. Not even our closest primate cousins have anything like it. So, laughing is the most human thing there is. But why do we laugh? Well, it's actually a field of study that's still being explored by both anthropologists and biologists. But according to the latest research, it's believed to be a form of communication between humans that evolved to subconsciously ease the tension within a group. If you pay attention, we often use laughter as punctuation, and it naturally emerges in interactions between people. It can also emerge when we encounter a new logical pattern, which is why jokes work. So, laughter is like the exhaust gases of our brain in the sense that it's something that happens when our brain is working the way it should. Cooking food. Our evolution was forever changed when we learned to cook our food. It might seem insignificant, but in truth, it's one of the things that sets us apart from other animals. You see, cooking makes both chewing and digesting food much easier for our bodies, so we don't need stronger jaws or teeth. In fact, human jaws shrank significantly when we started using fire to cook, and you can even see this in the fossil record. Cooking your food not only helps get rid of dangerous bacteria, but it also allows us to extract more calories from each meal, which is important when you have a brain as demanding as ours. It's interesting when you think about it because cooking made it possible for our brains to grow a bit larger, which then allowed us to discover new foods to cook. And the cycle repeated until we dominated the world. So now you know, those YouTubers telling you to eat raw meat are basically unevolved apes. Humans got to where we are today because we started cooking our food. Persistence hunting. Did you know that humans are naturally persistence hunters? Yes, that's right. We can't run as fast as cheetahs, nor do we have the explosive strength of tigers, but we are still dangerous predators simply because we're stubborn and don't give up easily. Here's the deal. Humans aren't as fast or strong as other animals, but we move much more efficiently than other predators thanks to our bipedal walking. And because our skin is exposed and we sweat, it's actually difficult for us to overheat, so we can chase an animal for much longer than any other predator. This means that it doesn't matter if the prey outruns us in the early hours of the hunt. Since it takes us less energy to move and our bodies don't overheat easily, we can keep chasing the animal for hours without getting too tired. It doesn't matter if the hunt takes several hours, at some point the prey will overheat and collapse from exhaustion, giving us the chance to finish it off with little struggle, unlike lions or tigers. Trust me, when an antelope has been running for hours, it doesn't put up much of a fight. Cheetahs, for example, can reach speeds of up to 60 miles per hour, 96 kilometers per hour, but only for 30 seconds. Humans, on the other hand, can walk briskly for hours and hours. Try it yourself. Walk quickly, not running or jogging, just walking at a good pace without stopping. You'll see that you can maintain that rhythm much longer than the 30 seconds a cheetah can sustain, and more importantly, you can cover much greater distances than the 3 miles, 5 kilometers, a gazelle can reach by running. Now it's your turn. What do you think helped us evolve the most? Leave your opinion in the comments. Here are 2 options that you'll surely love.